Steps to solve Newton-Raphson method. If the given function is f of x, step 1. Find the derivative, which is f prime of x. From the formula of the Newton-Raphson method, which is x sub n plus 1 equals to x sub n minus f of x sub n or f prime of x sub n. This is the given function at numerator, and it is the derivative of the same function at denominator, where n is the integer. Let me explain Newton-Raphson method graphically. This is my x-axis. Here is my y-axis. This is my function f of x, which touches x-axis at two places. Suppose that I want to find the second point, and to get that target I will take one initial value around it. Let's suppose that this is my initial value x sub n. I assume this here. Let me connect it with the curve. Draw a tangent line exact at that point where it touches the curve. The end of the tangent line touches the x-axis at this point, which is my x sub n. X sub n is the approximate value of the first iteration. This is my first iteration step. Let me connect x sub 1 with the green curve, which is the function f of x. Draw a tangent line again at this point where it touches the curve. The end of the tangent line touches the x-axis at this point, which is my x sub 2. So x sub 2 is the approximate value of the second iteration process. Let me connect it again with the curve and draw a tangent line at this point again. The end of this tangent line touches the x-axis at this point, which is my x sub 3. X sub 3 is the approximate value of the third iteration process. Connect x sub 3 with the curve and draw again tangent line here. Remember, the tangent line must be at the point where it touches the curve. So the end of this tangent line touches the x-axis at this point, which is my x sub 4. So x sub 4 is the approximate value after fourth iteration process. Because x sub 3 and x sub 4 have almost similar values, they are the two successive iterations coincide up to the desired level of accuracy. And one of the most important point is that whenever you want to assume the initial value, which is x sub naught here, you should not choose the peak value, the highest value of the curve. Because when you draw the tangent line at this point, it is parallel to the x-axis. It will only touch the other peak of the curve. So it is not possible to get closer to the target. Therefore, whenever you want to choose the initial value, it should not be the highest point. I can replace f of x sub n or f prime of x sub n with the delta x. Look at the graph. Delta x is here, which is the change between the initial value and the target. Height is here, which is f of x sub n. And slope is here, which is f prime of x sub n. So far I have explained Newton-Raphson method graphically. Now if you want to solve any numerical using Newton-Raphson method, the first step will be to take its derivative. In step 2, identify the initial guess, which is x sub naught. It is the initial value that we assume somewhere around the target. In the third step, I'm going to find the real root. So once I find the real root, then I will start the iteration process. The formula of the Newton-Raphson method is here, which is x sub n plus 1 equals to x sub n minus f of x sub n or f prime of x sub n. Substitute the value of x sub n, which is the initial value, in the formula to get x sub 1. X sub 1 is the approximate value after first iteration process. Repeat the same process and put the value of x sub 1 in the formula to get x sub 2. X sub 2 is the approximate value of the second iteration process. Repeat the process again and substitute the value of x sub 2 in the formula to get x sub 3. X sub 3 is the approximate value of the third iteration process. Repeat the process again and substitute the value of x sub 3 to get x sub 4. X sub 4 is the approximate value of the fourth iteration process. Let's suppose that x sub 3 and x sub 4 have similar values. Once you reach the point where the final two iterations have similar values, then you're gonna stop the process here. So I'm gonna stop the process here because x sub 3 and x sub 4 have similar values. The same will repeat in x sub 3 and x sub 4. So this process involves 4 iterations. Let's suppose that after first iteration x sub 1 was 3. After second iteration the value x sub 2 is 2.745. After third iteration the value is 2.555. After fourth iteration process the value repeats itself, which is also 2.555. So the final two iterations have similar values up to the desired level of accuracy. Therefore I'm gonna stop the process here, otherwise you have to continue until to get at that stage. Look to the diagram, my x sub 3 is 2.555 and x sub 4 is also 2.555. Keep this in mind that it is not guaranteed to get the exact value. These are the approximate values. You have to go closer and closer to the target. That's what Newton-Raphson method means.